Hello participants, once again welcome back to this online course Advances in Chromatography. We are going to discuss today preparative high pressure liquid chromatography. Whenever we say preparative high pressure liquid chromatography, first of all let us once again make very clear the difference in analytical as well as preparative HPLC. There are few important aspects that are to be made very clear, one of which is the sample if goes directly to the waste after coming out of the detector, we generally keep it in analytical HPLC. But if we are collecting the sample and providing it to a fraction collector to separate it, store it, and to reuse it for further research, we generally coin it as preparative HPLC. If the internal diameter of the column is quite small, it is analytical HPLC. When we say that it has a larger internal diameter, it is something related to preparative HPLC. And these diameters are for the column. And they are internal diameters. Less than or equal to 5 micrometer is the particle size of the stationary phase. Then it is analytical HPLC. But if it is higher than 10 micrometer, then it goes to preparative HPLC. Less amount of stationary phase is required in terms of weight when it comes to analytical HPLC, but a more amount of stationary phase in terms of weight is required when it comes to preparative HPLC. The flow rate is up to just 2 ml per minute in an analytical column, but in a preparative column it can go up to 100 ml per minute and much more. The sample size is quite small when it comes to analytical HPLC, and comparative to that in preparative HPLC the sample size is bigger or larger. Now, preparative HPLC is used for the isolation and purification of molecules of importance in industry as well as in research. The size of sample, apart from objective, also plays a key role in determining HPLC method to be either analytical or preparative. Generally, if you go back to the medium pressure liquid chromatography lecture and you check, it was very clearly mentioned that the objective is the key thing when you are defining analytical method and the preparative method. But the size of sample also plays a very key role, because if you check over here, the sample size is smaller in analytical HPLC and is larger in preparative HPLC. The size of sample also plays a key role. The ideal shape of the peak in an HPLC is a Gaussian curve, but overloading of the sample affects the shape of the curve, turning it to be broader. And to overcome this broadening issue of chromatographic peak while performing the preparative HPLC, selectivity of the column material is very, very important. And that selectivity of the column material is nothing but the choice of a stationary phase. And this is nothing but troubleshooting or throwing out the trouble of the broadening of a chromatograph peak in a preparative HPLC. So this is a very good competitive exam question, that how can you overcome the broadening of a chromatogram peak? You can come up by selecting a very particular column material, that is choice of an excellent stationary phase, and initially friends remember it is always done by trial and error method. Preparative high pressure liquid chromatography instrument, as you can see over here, is a very large instrument, and this blue color part, don't get confused, it's a column. Friends, it's a preparative HPLC. The column can be very much bigger in diameter. It can be about 1 inch, 2 inch of diameter. The components of prep HPLC again involves the same: solvent reservoir, solvent delivering pump, sample valve, preparative columns, detector, and fractional collector. I have purposefully coined the word preparative columns. The reason is sometimes multiple columns are stacked in a row to get perfect and purity based isolation of the mixed components. This is just an idea regarding the instrument that we are going to discuss, that is prep HPLC. This is a very important flow chart. Over here you can see that there are four vessels that are generally solvent reservoir tank. It is a gradient system. These are two access pump which are used to generate high pressure. through which this mobile phase enters into the sample injector, where you have an extra sample pump if required to give a thrust, because over here the sample volume is too much, and when the sample volume is high, always remember it can decrease the flow rate. So to increase the flow rate, to maintain the pressure, some extra thrust can be applied by using a separate section, that is sample pump, from where it goes into a column, from column to the detector, and from detector to the fraction collector. So the flow chart is simple. The only two important aspects that are to be covered over here involves: number one, an excessive sample pump component can be used, because the sample over here is not 1 or 2 milligram or microgram, it might be up to an ml or 2 ml, and when the sample quantity is larger, 10 ml, 15 ml, 20 ml. When the sample quantity is larger, sometimes you require a thrust to be given. You can very easily get prep HPLCs having the capacity in the loop form of a sample injector up to 30 ml. So friends, when giving a proper thrust, proper flow to this 30 ml quantity of a sample, you always require an extra pump. Second important thing, you have a fraction collector, where based on the lambda max determined from the detector, you can get the different or separate fractions for each component under study. Moving a step ahead, preparative high pressure liquid chromatography. We will be discussing three things, that is solvent reservoir, solvent delivering pump and columns. Inert glass material or stainless steel material is used for the collection of solvent reservoir, because these two are generally inert materials and do not react much with our solvent. And if at all they would react with the solvent, they can make several chemical processes which can lead to wrong results, wrong determinations. So it is very much essential to have glass or stainless steel made solvent reservoir tanks. Going towards the next step, that is solvent delivering pumps, we are generally using reciprocating pumps, and they are adjusted in such a way that they give a consistent and an accurate flow rate of the mobile phase, and the pumping capacity of these pumps can go up to 150 ml per minute. This excessive capacity of pumping through flow rate, excessive capacity of sample loading and sample handling, and the objective are the three main parameters on which prep HPLC, that is preparative HPLC, works. Column, large internal diameter up to 1 inch, and the length is moderate. The length has nothing much to do in prep HPLC. The chemistry is of the internal diameter, because when the diameter will increase, the radii will increase. When the radii will increase, A is equal to pi r square, the area will increase, which in result the volume will increase and the column will become more and more in volume, and so more quantity of the sample can be loaded and experiment can be performed. Moving a step ahead, sample valve in prep HPLC is very important. You can use a regular sample valve for moderate or less volume samples, but for a higher volume sample up to 30 ml, sample valve with a loop must be used. Now, what is this loop? Over here in this picture, you can see over here, this is your sample valve, that is sample injector. But this particular gray colored part where you can see coils like thing, these are the stainless steel tubules that can be also called loop, which have the capacity of 30 ml storage of your sample. And they are generally used in prep HPLC. Sample pump additionally may be required for higher volume of samples. You can see over here, we have a sample pump that is used when you are using a very high quantity of sample volume to be analyzed, isolate and separate in preparative HPLC. Preparative high pressure liquid chromatography. We are now going to discuss about the preparative column. Column size is determined by the amount of material required to be injected. More the amount of material required to be injected, more would be the internal diameter of the column. You have a normal analytical column. Sometimes fortunately can be used in preparative columns, that is 4.6 millimeter, but generally you use 7.8 millimeter or 21.2 millimeter columns for small scale experiments. But for semi-preparative HPLC and large-scale preparative HPLC, columns can be scaled up to the diameter of 30 to 50 millimeters, and sometimes they go up to 1 inch and more than 1 inch. Keep these things in mind, that column size is very much important in preparative high pressure liquid chromatography experiments when you are interested in isolation and purification. Conventionally, silica gel, alumina, and Keshulgar based adsorption chromatography has been used for purification of many organic compounds. But today, as we all know, reverse phase chromatography has gained the most popularity both. Let it be analytical, let it be preparative HPLC. So you can mention very well and write in your notes that RPC, that is reverse phase chromatography, the C18 columns, the C8 columns, the C4 columns are the most popular columns that can be used in both analytical chromatography as well as preparative chromatography. The capacity of adsorption chromatography column depends on the surface area of the adsorbent. You know, when you have a larger surface area, the capacity to attract the sample will increase and the retention time will be more. You can see over here in the slide, it is very clearly mentioned that RPC, that is reverse phase chromatography capacity, also depends on the quantity of surface silanol groups. This is also very much important. So there are two factors, two aspects that are important. Number one, surface area. Number two, silanol group. Now comes the question, what is this silanol group? Very easy, from its name itself you can learn. Silicon, that is Si, on all, that is alcohol. SiOH4. So it will be SiOH, 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 SiOH. This will end up as silanol. So friends, more the number of OH group, more will be the hydrogen bond, more will be the binding. More the surface area, more would be the attraction, more would be the binding. So in both the cases, for an adsorbent, for a reverse phase chromatography, for a stationary phase, more the surface area, more would be the binding, more would be the retention time. More the silanol groups, more would be the binding, more would be the retention time. Greater the surface area, more are the signals present and higher is the retention. So in reverse phase chromatography, hydrophobic interaction between the analyte and stationary phase results in the separation. So remember these things very well, that hydrophobic interactions play a very important role when it comes to the chemistry between an analyte and a stationary phase. Friends, in the basic chromatography section, there were 11 videos, and in most of the videos earlier, I have always tried to mention one thing for you, that the chemistry of your sample and the stationary phase is the key factor in the separating game in chromatography. And the similar thing is revealed over here when we are doing this prep HPLC. Let us move a step ahead and see what can be happening. Preparative high pressure liquid chromatography has a very good process development. See, remember very well, when you are desirous of a high purity final product, then never think of high yield. Success of prep HPLC is dependent on three factors: product purity, throughput, and yield. If I am desirous to have a very good pure product, then yield might be less. And if I am thinking of a high yield product, my purity might be low. So you have to compromise yield to get very much pure product. You have to compromise very high purity if you are getting a high yield. So if you want to be in a win-win situation, go for optimize, not for ultra results, but for optimized results. So friends, depending upon this optimization, what are the changes that are required are to be discussed now. Second important thing is, I am developing an analytical method and I want to scale it up to a preparative method. What is the process for that? That is the key factor that I am here going to discuss. One more thing I want to make it very clear. The subject basics in chromatography was quite easy, quite lucrative. And even the videos were for 1 hour 10 minutes. Over here, if you have observed from the first video of MPLC, we have cut shorted the time to 32 minutes because now we are in the advanced stage. We want to do less, but we want to make the concept clear that can be useful to you at your research level. Preparative high pressure liquid chromatography process development in a nutshell. See, selection of solvent system. Always go for a gradient system to get proper results. The loading amount of the sample has to be optimized. And the third step is scaling up from analytical to preparative via column size, flow rate, and gradient. So let us do one step in detail. Selection of mobile phase is very much important for prep HPLC. Mobile phase is chosen keeping in mind the desirable properties such as selectivity of the analyte, purity, volatility for easy removal, low viscosity to avoid development of unacceptable back pressures and low cost. So, mobile phase property is very much important while its selection to be used for prep HPLC. Mobile phase has to be pure, it has to be volatile so that you can easily remove. It has to be low viscous so it does not stick. These are the properties of a mobile phase which are essential. Mobile phase compatibility with the detection method is another important criteria. If your mobile phase gets interfered as a peak, then you might get a wrong answer. If UV visible, this is the explanation. If UV visible detector is used, then the UV transparency of the mobile phase is important. Similarly, for other detectors, properties of the solvent such as fluorescence, compatibility with mass spectrometer is also considered. Volatility of mobile phase facility facilitates its removal from the isolated fraction. Someone has asked me a question in the first video itself, MPLC, that sir, when the fractions get separated, what about the mobile phase present inside? This is the answer to that. Generally, mobile phase have a boiling point below 80. So simply you can remove them either by boiling, and if they are very low, then at an elevated temperature you can get the volatility of that mobile phase and its removal from the isolated fraction, and hence you get pure product. But over here, as written, if the mobile phase is volatile, you even not required to elevate the temperature or heat the system, it gets volatile or it gets evaporated and you always get a pure product. So this was the first criterion, that is selection of mobile phase, which is very important. Coming to the second part, optimizing the load volume. If you go back to the MPLC video, we have tried to justify it very well. Once analytical method is developed, loading volume is determined by making a series of injections of representative samples with increasing volume. Means first I will add 1 ml, I will add 2 ml, I will add 3 ml, and I will check the chromatogram. Until and unless I get a sharp chromatogram or a Gaussian chromatogram, I am happy. But at that particular volume, when my chromatogram peak turns from a sharp or a Gaussian to a broader one, I'll stop. That particular volume for that particular experiment will be my optimized load volume of the sample. You can see it over here. I am repeating it again. You can increase the volume of sample when you are jumping from an analytical method to a preparative method. But how can it be done? Friends, always remember in science, trial and error is a very important aspect. So over here, I'll start injecting 0.5 ml, 1 ml, 2 ml, 3 ml, and for every injected sample, I will look for the chromatogram. Until and unless I am getting a pure chromatogram, a Gaussian curve, or a peak, I won't worry. As soon as this peak broadens up, the shape of the Gaussian curve changes, I'll stop. So the last volume until which the Gaussian curve was in shape would be considered as the optimized load volume for this sample. The shape of the peak is observed and the acceptable maximum load volume is determined, that gives symmetric sharp peak. It is advantageous to use detectors that can analyze the desired analyte as well as the impurities that need to be removed. This is important. Preparative high pressure liquid chromatography. Always remember the 2 and the 1 stands respectively. 1 stands for analytical, 2 stands for preparative. The suffix 1 and the 2 written over here. The subscript, sorry, not suffix, the R1 subscript and R2 subscript, the above 2 is square. R1 and R2 are respectively for analytical and preparative. Now, this is a mathematical equation for optimizing the load volume. And for an analytical column, if I am going to inject 4 ml or I am going to inject 0.4 ml of sample, then what maximum ml can be injected for a preparative column? I just need to know the internal radius of the analytical column, the internal radius of the preparative column. Putting those values over here and the maximum analytical injection volume, I can get the preparative injecting volume. For example, in an analytical injection volume, I am using 0.2 ml. The radii for preparative column is 50 mm and that for analytical column is 4.4. So it is 0.2 multiplied by 50 divided by 4.4. And the answer that I get is the maximum volume that can be loaded as a sample in the column or in the injector. So the volume of the sample that can be separated depends directly on the column volume. Generally, it is assumed that the column length remains the same while the diameter is increased. Friends, never change the length of the column, it will affect the resolution. Always change the diameter of the column while optimizing. Volume that be processed. Injection volume is proportional to the cross-sectional area. So over here, remember this formula. You, while appearing for your tests over here in this course or even in the competitive exams, this will help you somewhere that the preparative injection volume is equal to the analytical injection volume multiplied by R2 square divided by R1 square, where the subscript 1 refers to analytical column and 2 refers to preparative column. Optimizing the flow rate. F1 is the flow rate for analytical, F2 is the flow rate for preparative column. R1 and R2, as you know, the flow rate of analytical column is known, the flow rate of preparative column is to be found out. So the flow rate in preparative scale chromatography are proportional to the cross-sectional area of the column, that is F1 multiplied by R2 square divided by R1 square. Sometimes, apart from using radius, people are also using diameter. Keep these two formulas intact with you. They are going to help you very much while calculating these prep HPLC equations. Troubleshooting tips for prep HPLC. If you are getting a chance sometimes to use prep HPLC or a person who is constantly using prep HPLC, the impurities in the sample may get deposited at the head of the column, at the starting point of the column, leading to change in the peak shape and retention time. Impurities result in increased the column pressure. Therefore, the columns are occasionally flushed with stronger solvents. Solvents that have the capacity to remove the impurities either by attraction or by dilution can be used as washing material, which are generally called the purging solvents. Buildup of a material in a peak pack column occurs most frequently when the injection solvent is weaker than the mobile phase. Now, what is this buildup? The extra clotting that occurs in a stationary phase column is called buildup. This can be observed commonly when an isocratic elution is used. Generally, as an elution or eluting solution, isocratic is not preferred, gradient is preferred, that is a combination of two or more than two solvents. The use of a stronger solvent leads to better removal of strongly held impurities during elution. So friends, these are some of the very important points that are directly related to prep HPLC. Few things that I want to make very clear over here. The first three videos, that is MPLC, Prep HPLC and UPLC, are comparatively shorter in length. We have kept them shorter purposefully, keeping into consideration several aspects of the participants who are there in this online course and those who are going to see this video even after this course. But from the second set of lectures, the length of the lectures is also going to increase. Friends, do not forget to provide your feedback to us. Your feedback is quite important for us. If you have any queries, get in touch with me. This is all for preparative HPLC. Thank you very much.